So if you've ever went out on social media, I don't know if you've ever done this, go to Reddit, go to LinkedIn. What do you see as the major reason why people think data projects fail? Well, it's because they use Snowflake instead of Databricks, and so their costs were different. That was why they failed. Or it was data lake versus whatever. They needed something else. They needed a data swamp maybe, or they needed this data other thing or that data other thing. That was why they failed. Or they used the wrong language. They should have been using Python because Python is the new hotness of this is how we should be doing it. Or they shouldn't have used Java, or they should have used Rust. Rust is why things either succeed or fail now. So are these the reasons why projects succeed or fail? No. Technologies have a place. Don't get me wrong. Technologies do have a place. Languages do have a place. But they're not the, at least initially, they're not the reason teams either succeed or fail. So just how bad is the failure rate? So this number, 85%, is a number that Gartner put out a while ago. It also corresponds to what I've seen empirically in my own consulting. So if you invert this, that means only 15% of data projects succeed. They actually get into production. So this is a pretty terrible number. It's the amount that people should be even giving pause. They should say, 15%, I don't think I'm even going to try that. It's such low odds. So why is it so bad? Why can't we create more value with data? And maybe it's we didn't have ChatGPT telling us what to do, but that's not going to help either. These sorts of problems are much deeper than that. So as I mentioned, technology is just one small piece. It's an important piece, don't get me wrong, but still there's other parts that are much more important with data. So what we have to do is we have to ask the right questions. What are the questions? Who, what, when, where, and how? If you don't have the answers to these questions, you're going to need to go answer them before you do this. So even if you're in the middle of a project right now, you need to be asking yourself, do you have these questions answered? Or if you're about to embark on a project, make sure you have these questions answered. Maybe you jot them down like Dave Thomas talked about, right there on a piece of paper and say, here's my who, here's my what. So let's go through what each one of these questions means in detail so that you can answer them and have a good answer for this. Let's start with who. Who is probably the most important one, and it's who are the right people at the right ratios. We'll divide this up into two parts. The right people. This is an important thing. I've been thinking about this a lot lately of who is the right person. Who is a key thing of who can do this. So oftentimes when we talk about technology, there is a friend of mine who I interviewed for my book, and he said people would come to him and ask him what technology should they use? The reality is that they were lacking the person on their team to be able to tell them this, to be able to vet this, to be able to answer that question for them. So now they're coming to somebody from the outside to tell them, hey, here's a shot in the dark for you. So when you are missing that person, that's a big problem. We need data scientists. We need data engineers, and we need operations engineers. And let me give you my definition for all three of these. So, and it's an important thing because each one of these definitions tells you about who it is. So a data scientist, my definition is a person with usually a mathematical background who's learned how to code and applies that to some sort of artificial intelligence, machine learning algorithm, okay? Then my definition of a data engineer is a software engineer, once again, a software engineer who has specialized their skills in data. And that specialization of a software engineer is key here. And then we have our operations person. An operations person is someone who has learned how to operationalize these data frameworks as well as your own code, because there's two parts to operationalization, if you didn't know. So operations engineers, these people are ones who have an operational background and apply it to these data frameworks. So it's an important part where there are two parts to their job. One is the actual operationalization of these frameworks, whatever, Kafka, Spark, whatever. Those frameworks have to be maintained. And then there's your code. And that's a whole different thing. There's nobody that you can call or put up a thing up on Stack Overflow and said, why did my code fail? Your operations team in conjunction with your development team has to answer that. So now let's circle back to why each one of these definitions is important. So your data scientists, if you rewind back 5, 10 years, your data scientists were the ones who were ostensibly put forward as the ones who know all of this stuff. They aren't. Your data scientists generally do not know how to code well. They've learned how to code as out of a matter of need. They've learned how to code. They've went through a boot camp. They've maybe in college, oftentimes, they've learned, taken 1 or 2 classes on coding. Coding is not the memorization of syntax. I can't stress this enough. Data scientists have memorized some syntax. They know how to do some things to accommodate and have math run. They are not software engineers. Software engineering is not writing code and putting some syntax and having it compile. Software engineering is knowing all the best practices of engineering. It's making things repeatable. It's making good systems. It's exposing data the correct way. And these are skills that are not present in data scientists. And this part goes to that definition of data engineers as that specialization in software engineering, that these software engineers know how to use best practices of software engineering. They're not just writing code, they are putting forward things like continuous integration. They're using that. They're exposing data products the right way. This is the difference between a data engineer and a data scientist. The data engineers are the producers of data products. The data scientists are consumers of data products primarily. That difference is important because if you have a data scientist produce a data product, it's often not produced correctly. Not from an engineering point of view, is not produced correctly. So what we have is we will have data scientists consume that data, and this is key because all 3 of these people, these groups of people, need to be at the right ratios. A common mistake here is that teams or companies will have a ton of data scientists to 0 data engineers. You may have maybe dealing with that in your organization. What that looks like is a lot of data products that can't be used. And they can't be used because, back to that definition of the data scientists simply don't know how to do this. This isn't a failing of the data scientists, this is a failing of the management to understand this and understand that this person can do something, but that is not their thing. They need these data engineers, and they need these data engineers in the right ratio, because a data engineer, or the data engineering part of AI, of all of these generative AI, of these sorts of problems, is far more in the data engineering domain than it is in the data science domain. So oftentimes I get asked this by management, which team is the most important? Because that's the team I'm going to hire. I can just do one. I can only do one of these teams. So which one's the most important that you see in this? Is the most important data science? Is the most important data engineering? The most important operations? The answer is none of them. Each one is equally important to get this value chain done. And if you're missing one of them, it throws this off. I have an entire talk where I talk about the manifestation of when these teams is missing. But if you're missing data science, for example, you're not doing everything you can with data. You're actually missing the cherry on top, where I would say, if you're doing all this data work and you don't have any data scientists, you're missing a pretty significant amount of the value you can create with data. Data engineering. If you're missing your data engineers, you are not going to have the engineering excellence for these data products to be exposed the correct way. It looks like a house falling in on itself all the time. And that's the visualization I use in that talk. There's a house where the roof has just caved in. And that's what it looks like when you walk into a company without enough data engineers or without any data engineers. Every time they've tried to stand something up, the roof caves in and they wander around scratching their heads. Why did this happen? This happened last time too. Missing data engineering. Operations, if you're missing your operations team, you're never going to have that excellence, that operational excellence that the business can rely on. The business can never rely on it, and they always say, why is this always down? It's never up. I try to go get this, or I try to deal with the data quality, and it's never there. the operational excellence is missing. Very clearly, each one of these teams is required for success. What is the business value? How many of you have worked at a company where your business value is, we're going to do some sort of AI? So there's some sort of AI that you're going to do, and that AI is that's the value that's going to happen. Yeah, that's not value. So what we need to have is we need to have a clear and attainable path to value creation. If we don't have this, we will lose. And a key part of this is that it's attainable. If you have a goal that's put forward that's unattainable, that's a pipe dream, you're never going to hit it. You're never going to hit that business value, and as a direct result, you'll never be able to attain what the business thought or was promised. So sometimes a data strategy is what's put forward. We have this data strategy. The CEO said we're going to be a data company now, and that's it. Everybody can go home. We're now going to create value with data. The CEO said we have a data strategy. No, we need to have a plan, and we need to have clear execution. If you're lacking this, then you haven't answered this question. You need to have clear ways that you are going to achieve business value. When? When are you going to generate that value? This is an important question because sometimes there's a lot of assumptions all over the place about when this is going to happen, where the business thinks, oh, tomorrow. I was told by some vendor that their tool is so easy that you can do all this in a week. And so they have that in their mind. And then when you go to actually do it, they're mad. It's taken you months. Why haven't you got something out? So these unattainable timelines aren't feasible at all. And conversely, sometimes engineering teams get into this when it's ready. And this when it's ready mindset doesn't work either because you inevitably don't have enough time. You do need to show some amount of value on a timeline that's feasible, or a timeline that the business can deal with it. So projects that take too long are going to get canceled. And I think this is especially true as we start getting into worse economic times or gradually in decreasing economic times. So what we have to do is we have to make sure that our projects are showing some sort of value. Although you were told that you have a year, let's say, you probably don't have a year. You need to show some value much sooner. And I would strongly admonish all of you to take a look at that and see if there's some way that you can show some amount of value. And conversely, if you promise too much too soon, you're not going to meet those expectations either. So try to make sure that you have a balance and that you've not just chosen a win, but you've communicated that win quite well. Now we have where. Where will this data be processed? We do need to have a good architecture in place. You heard me talk about that technology, but we need to have this clear plan of where this will be done. Is this going to be on-prem? Is this going to be on cloud? Is this going to be on edge devices? Is it going to be a mix of all three? This where is important because it dictates some of the changes or some of the choices that you'll make. If it's in the cloud, you have much more opportunities to how big should your operations team be, for example? Or if you're in the cloud, now you can use managed services. It opens up some possibilities. However, if we just follow a vendor or a cloud provider's diagrams or recommendations, you may be using the wrong tool. So what this means is, let's say your cloud provider has a pub sub, okay? Is that the right pub sub, publish subscribe system, or is that the wrong one? Well, just because they have one, there's various limitations to each one. There's various nuances and caveats to each one. Do you know them well enough to make that choice correctly? So just choosing and saying, cloud provider gave me this diagram and they put their pub sub right there, is that the right thing? Or if a salesperson comes in and tells you, our product is so easy that you don't need anything else, well, that's another issue. You're going to have to vet these yourselves because guess what? The vendors, the salespeople's job is to get you to use their product. It is not to make sure that you use the right product. It is not to make sure that you're well off. It is to make sure that they get sales, okay? So make sure that you have, you vet those recommendations. Next we have how. How are we going to execute this plan? So what we need to do is we need to have a clear plan of what we're going to do. My biggest suggestion here, probably one of the biggest suggestions out of the talk if you're just starting this, is to have a very singular focus. You focus on 1 to 3 things while you're doing this. The issue here is if you can go a lot of different ways. You heard Dave talk about fractal. With data, you can go on this fractal journey, and it just explodes out in complications. So if you don't have any sort of focus, you won't be able to get there. You'll go in many, many different ways and many, many different directions. If you come from a computer science background and you think of this as a CPU, what happens if you overload your CPU with way too many threads? You get issues of thread swapping, because everything has to be swapped in and out at the CPU level, the CPU instructions. Guess what? Humans can do that, but they don't do that as efficiently. And so that swapping, that context swapping that happens with humans, it takes them far more time to do that swapping. As a direct result, you're going to have much less efficiency. So data teams, you should really be focused. You'll go out bogged down way too many different directions. Get focused, 1 to 3 things, execute those things well, and then move on to the next thing. I'll give you a bonus, and that is, why is data valuable? Has anybody answered this question? You know why you want to ask why? It's because eventually somebody with an MBA, a Master's in Business Administration, is going to come up to you and say, you have €1 million a year in cloud spend. Why do you have this? What's the value of this? And you're going to need a pretty good answer to that question, because the technical answer of, well, we need that for a Spark cluster, or we need it for this or that cluster, they don't care about that. They just look at numbers on a spreadsheet. So if you don't have very good ROI or a business value, then your project, your cluster, you could find them just taking your budget away. So generally what I look for is a 10x ROI. That 10x ROI, so if you've invested €1 million, theoretically you should get €10 million in value. And the reason that you do that is maybe you don't hit that level of value, but it could also be that you hit 5x of value. Whatever happens, you're able to show, by us investing this amount, we get a disproportionate amount of value out of it. And if you can put it in those terms and you can position it in those terms, when an accountant, when an MBA comes knocking, you're going to be able to say with clear certainty, this is what we want, and this is what we're getting. So what you want to do is, if you're in a project, if you're either starting a project, in the middle of a project, start answering these questions. Only then, once you've answered these questions, then you can move on to into the execution phase. It's very important that you do this. Another thing that you should realize is that not all gaps are in technology. Sometimes you just look at a team or a company and you say, we need some Spark, or we need some fill in the blank. What we do need to check for is gaps in people and technology. So that people part is very important. You heard me refer to that quite a bit of, do you have the right definition for your data engineer, for example? Do you have your data engineers at the right place and the right ratios? If you don't have these people, you're going to start out with these gaps that are difficult, if not impossible, to replace without people in there. So this is especially true in the GPT, the chat GPT age. Your CEO, maybe in accounting, whoever MBA, is going to think, I can just replace you with GPT, or GPT told me that it can generate all this code for me. You're replaceable, perhaps. And so what we need to do is we need to help educate these people of that GPT-generated code is not the biggest problem that data engineers are looking for or dealing with. It's the biggest issues are usually organizational, trying to get the right information from your business people. That's usually your difficulty, and that doesn't come across in a chat GPT prompt. It's about organizational, it's about people, and it's a skill change. that skill change is important. So one important part of that specialization that you heard me talk about with data engineers is that you do need to understand at a minimum some technologies in a great deal of depth and a bunch of other technologies at a cursory level. There. So should you get help? When should you get help? This is important because there's all sorts of different possibilities out there. There's outsourcing, there's people that will do it for you, there's management consulting. Each one of these possibilities is out there, but I really want you to take away that these problems that I mentioned don't go away by themselves. Put a different way is just time won't go by and all of a sudden it's done. These problems have to be done with concerted effort, otherwise they just won't happen. You just won't be able to fix them. So if you're trying to figure out how to do this more, how would you do it with the number of people you have, or how do you set this up? I have a book I've written called Data Teams. It's at datateams.io. Please, you can reach out and read that book. And with that, I'd love to hear your questions, and a big thank you for being here.